Welcome to Section 4, Networking of Kubernetes Objects in Detail. In this section, we are going to go deep into the inner workings of Kubernetes objects. We will cover various networking aspects of them. We'll talk about container-to-container networking. We'll also talk about pod-to-pod networking and more. This section is dense with information, so let's not wait any longer and get started. In this video, we are going to get familiar with the container-to-container networking model employed by Kubernetes. Let's get started. In Kubernetes, containers run within pods. They encapsulate applications usually running in one or more containers within them. Containers within a pod can communicate with one another as they share the same resources. They specifically share the network namespace, which includes the IP address and the network ports. Containers inside a pod can communicate with one another using localhost. A container running in a pod is not able to talk directly to another container running in another pod. This is due to the fact that they are isolated and scoped to the pod they are running in. Now let's get back to the terminal and explore this firsthand. From the terminal window, you can see I am already logged into the master node on my machine. In the current folder, you should already have a YAML file called 2containers. Let's go through its content for a moment. In this resource, we are defining pod running 2 containers. One container will run nginx, and the other will simply run the Python built-in web server. They will expose ports 8181 and 8080 respectively. Let's now launch the pod. With the pod scheduled, let's wait for it to run. With the pod running, I am going to show you how connectivity between containers works. Let's attach to the nginx container first. I am now in the nginx container. Let's now install curl, so that we can send web requests to it and a few other networking related tools. With the utility tools installed, let's use curl to call localhost and see what happens. As you can see, we get nginx's default index page. That means nginx is working and sending responses back to us. Now let's try to send a request against port 8080. This is the port the Python web server running in the other container should be listening to. Notice how the output this time is different. We did not get the nginx default page, but a directory listing instead. That was indeed the Python process sending a response to us. As I mentioned earlier, containers can reach each other as they are sharing the same virtual space. Let's now use the ifconfig tool to get the networking setup of this particular pod. Notice the inet address under the section of the first Ethernet interface, also known as etho. Now let's get out of this container and go into the second container to see whether there is a difference. From inside the Python container, I will now install the same set of tools. Okay, with the tools also installed in this container, I will run call localhost to see whether the two web servers return the expected responses. The Python web server works. Let's now try nginx. As you can see, we can also get a response from nginx, as expected. Let's now check the container IP address. Notice how the IP address is the same. That is expected. Containers are exposed to the outside world via their pod IP address. The reason why they can reach each other is because they share the same network namespace.